So this is a video to address the end of chapter 4 foundation biology test, and it's the second part to question number 6. So we were at C part 2. So on the graph paper below, draw a graph to show the student's results. Add a label on the vertical axis, plot the mean value of the number of bubbles, draw a line of best fit. So the y-axis, it's the rate of photosynthesis, that's the quantity you're measuring, and the unit you're measuring it in is the number of bubbles per minute. So a rate of photosynthesis slash number of bubbles per minute, I think, is a good option there. So in terms of plotting a graph, you should use a sharp pencil and you should use crosses, and you should take the time to get the crosses in the right place. So if you're more than one, well, if your cross isn't precise to the nearest square, you will lose marks. So the next thing to point out is that you clearly haven't got a linear relationship here. Your crosses do not represent a straight line. So you should draw a curve of best fit here. Now if I had loads more points, I could use a slightly different technique where I fitted a curve which had as many above as it did below the line, but there's not enough points to use that technique here, so I'm simply going through with one smooth continuous curve. It's not wispy or hairy, and I've joined up the points, which is the best thing to do here. So so last part, one student concluded that the rate of photosynthesis was inversely proportional to the distance from the lamp from the plant. Does this data support this conclusion? So it's only a 2 marker. You can do this on a qualitative level, which means only using words, or you can do it on a quantitative level, which is using numbers. So on a brief level, just using words qualitatively, if your distance is getting larger, if it's inversely proportional, your rate of photosynthesis would be going down. So as the distance is going up, the rate of photosynthesis is going down, and you can see that this is broadly happening, especially between 20 and 40 centimeters. The effect isn't quite as clear between 0 and 20 centimeters, so that might be significant. You can see a little decrease between here and here, but it's not as significant as between here and here and here and here. So let's flick to the answers. So as long as you've got no bubbles per minute on the y-axis, you get a mark. If you got 3 out of 4 correct to the nearest small square, you get a mark. If you got all 4 correct, you get 2 marks. In this case, all they were looking for was a smooth curve to recognize it wasn't linear. Linear means a straight line, by the way. The last parts, so as distance increases, the rate decreases between 20 and 40, and essentially it's less clear between 10 and 20. It's a little bit straighter than an inversely proportional relationship would suggest. Okay, so 15 seconds left. I'll address this in the third part to question 6. Thanks very much.